So this is lesson 4, which is part 2 of our work today. And we're looking to summarize our ideas. So there's a nice summary replacing x with minus x. That's a reflection in the y-axis. Replacing y with minus y. That's a reflection in the x-axis. And if you flip x and y, you're getting an inverse. So we get a little bit of a practice of that. If y equals x squared, what happens if you reflect in the line y equals x? Well, that means find the inverse. So I've said x is going to become y is going to become x. So x is equal to y squared, and then I get to say that y is equal to plus or minus the square root of x. Reflection in the y-axis, how do I remember that? Because I'm reflecting in the y-axis, I know that it's the opposite variable that gets flipped. X has to become minus x. And that's all I have to do in this statement. Y is going to become 10 to the minus x, and I'm done. A reflection in the x-axis means take the opposite. It means my y is going to become minus y. So minus y is minus the square root of x. So I'm looking on the other side of that equation. Continuing with similar work, I'm looking at class example 2 and trying to figure out how do the graphs compare. Well, I've gone from y equals x cubed to y equals minus 1 x cubed. So that's a reflection in x because I manipulated my y. It's also possible that this is viewed as my x being replaced with that negative, just depending how those brackets are interpreted. So that's a little bit of a tricky one. Brackets end up being a little bit deceptive there. So it could be a reflection in the x because y became negative y. But it could also be a reflection in the y, and that would have been obtained by x becoming negative x, and that cube is just a little bit deceptive. In 2b, clearly the x's and y's have flipped spots. So this is inverse, and on inverse, x becomes y and y becomes x. And this one's nice, nicer with the brackets. My x's become minus x. And when I manipulate the x's, that's a reflect in the y. Good job. I'm sad I'm coming to the end of the day because my orientation is finally back and I don't know what I did different other than turning it on and off. What has happened in these graphs? You're going from thin graph to thick graph and trying to understand what happened. I can clearly see the mirror in this one, in that this is my mirrored line, which is the x-axis, which means my y has become minus y. What's happened in the first graph? That first graph is not a mirror reflection in x. It's not a mirror reflection in y. It must be an inverse. My x's became y's and my y's became x's. And that's a graph shape that you're probably a little more familiar with. And we'll finish up today with practicing our skills. So when I see x equals fy, I'm noting that that has to be inverse. When I see x equals f to the minus y, what is that saying? And then x equals minus f to the y. This is some weird inverses. So I'm going to first find my inverse, which means I write out my original statement, y equals 3x plus 2, then flip for x's and y's. So x is equal to 3y plus 2. And then finally, x minus 2 over 3 would be equal to y. Now my next statement says work on your inverse, but make your y's a negative y's. That's what that's saying. Make your y a negative y. You can see here my orientation is a little weird in the middle. So I can continue with my red statement. My y has to become minus y. So that means that on the other side, I'm going to have some sign changing when I resolve for y again. Divide by -1 will actually mean my final answer is -1/3 x plus 2 over 3 is equal to y. Just so you can more clearly see those signs. And then the next statement is actually asking me to change my x's. So the inverse notation is a little bit weird to get used to because it's already been flipped. This is actually asking me to make my x's into minus x's. So I can go back to the original inverse statement, and wherever there was an x, I can write a minus x. And that's only going to change in one location. So we see how the inverses are dealt with. You can go ahead and graph them on the grid paper that's below. Use your graphing calculator now that we've got those y statements plugged in. I'm going to go back and just do the work associated with class example 4, talk through that. This example is a little bit more straightforward in that it's asking first for y to become minus y. That can be clearly read. Here it's asking for x to become minus x. And the last one is looking for an inverse. So just practicing those skills, trying to recognize what's being asked for. It was a little more challenging in the inverses. So y with minus y is minus y equals 6 over x squared plus 3. And I need to move that negative over. I'm just going to shift to the left. So that would be minus 6 over x squared plus 3, which would be what y is equal to. In the middle one, when x is replaced with minus x, actually nothing changes because I have to square it. So y will still be 6 over x squared plus 3. And then the joy of the inverse is to flip x and y. And I'll give myself a little more space for that. Y equals 6 over x squared plus 3. Then x is equal to 6 over y squared plus 3. Then I have to do a little bit of algebra, which isn't as much fun. The y squared plus 3 comes upstairs on the left. The x moves downstairs. And then I have to isolate for y, move the 3 over, and take the square root. So y would be equal to 6 over x minus 3. And then I have to take the square root, which in this case could be plus or minus. Thank you very much. Hopefully you can watch these lessons, and the majority of tomorrow's work can be work time on lesson 3 and 4. See you in the morning.